Right now, more than 4 billion people consider themselves fans of a single sport, one whose most essential object was, for most of human history, a dead animal's organ filled with air. In medieval England, entire villages played a game with no rules and no boundaries. Dozens of people kicking, punching, and carrying a crude ball through muddy streets for hours. The ball was a pig's bladder, inflated by mouth and tied at the stem. It was lopsided and unpredictable, and it smelled exactly like what it was. There was no pitch, no referee, no time limit. The goal was often a landmark in the next village. The whole town was the arena. These matches were played on Shrove Tuesday, on Saints' days, on any occasion a crowd could gather. They were less a sport and more a controlled riot with a ball. King Edward II banned the game in 1314. Later English kings followed with their own edicts. None of it worked. The game was too deeply embedded to kill. The pig bladder had one fatal flaw: it could not hold its shape. Kick it hard and it deformed, overinflate it and it burst. The perfect ball was centuries away. By the 16th century, cobblers began wrapping leather panels around the bladder, a crude outer shell that made the ball more durable and at least somewhat rounder. But every ball was still different. Different sizes, different weights, different bounces. Football was a game played with whatever someone happened to stitch together that morning. The best balls used cowhide panels, cut by hand and stitched by eye. The craftsman who built your ball determined how the match went. Quality was never consistent. In 1839, an American named Charles Goodyear accidentally dripped a mixture of rubber and sulfur onto a hot stove, and changed the history of sport. The process was called vulcanization. It made rubber stable in heat and cold, elastic and durable. Goodyear patented it in 1844 with no idea what was coming for football. In 1855, Goodyear designed the first vulcanized rubber soccer ball. It held its shape. It bounced consistently. It was a revolution, and most people have never heard of it. Meanwhile, in the English town of Rugby, a boot and ball maker named Richard Linden had been supplying balls to the school next door and facing a personal tragedy. His wife had spent years blowing up pig bladders by mouth to inflate them. She died young. Linden believed her work had killed her and vowed to find a safer way. Around 1860, Linden invented an inflatable rubber bladder that could be filled using a brass hand pump he also designed. No more mouth inflation. No more risk. Goodyear and Linden, working independently on opposite sides of the ocean, arrived at the same solution. The pig was out. Rubber was in. Football would never be the same. In 1863, representatives from English football clubs gathered at the Freemasons' Tavern in London and founded the Football Association, the world's first governing body for the modern game. They codified what the game was: no carrying, no hacking opponents' shins, and for the first time in history, they began to define what the ball itself should be. By 1872, the FA had settled on a circumference of between 27 and 28 inches. That rule, remarkably, stands unchanged today, 150 years later. For the next 80 years, the soccer ball was leather, hand-stitched panels wrapped around a rubber bladder, laced shut for a pump. Each one was made by hand. The leather ball had one notorious problem: it absorbed water. On a wet match day, it could more than double in weight, turning a simple header into a medical risk. Heading the wet ball was genuinely dangerous. Players knew it. Coaches knew it. The game went on anyway, season after soaking season, through the injury and the rain. After the Second World War, football was becoming a global spectacle. Television was arriving. The old waterlogged ball was no longer good enough for what the game was becoming. The breakthrough came with a design using 32 panels, 20 hexagons and 12 pentagons, arranged in a pattern mathematicians call a truncated icosahedron. It was the roundest shape achievable from flat panels. Archimedes had described this shape more than 2,000 years earlier. It belongs to a family known as Archimedean solids, geometrically elegant, and now finally wrapped around a football. In the 1950s, American architect Buckminster Fuller made this geometry famous through his geodesic domes, hemispheres built from interlocking hexagons and pentagons. The wider world was paying attention. For the 1970 World Cup in Mexico, Adidas introduced the Telstar, a 32-panel ball with 12 black pentagons against a white surface. It was elegant and entirely deliberate. The name came from the Telstar Communications satellite. The design was functional. High-contrast black and white, so the ball would register clearly on the black and white sets broadcasting matches worldwide. Overnight, the black and white ball became one of the most recognizable objects on Earth, drawn in notebooks, printed on logos, worn on shirts. A sphere had become a symbol. Surprisingly, that pattern was never officially mandated by any governing body. Other designs existed alongside it, but the Telstar dominated the culture so completely that everything else simply vanished. In the 1980s and 90s, leather gave way to synthetic materials. Polyurethane, nylon, polyester, lighter, completely waterproof, and far more consistent in flight than anything leather could ever offer. The wet ball problem that had plagued players for centuries was solved almost overnight. The ball now performed the same in rain or sunshine. The header was finally safe. By the 2000s, stitching gave way to thermal bonding. Panels fused with heat and pressure, creating a surface approaching a true sphere without a single stitch in sight. At the 2010 World Cup in South Africa, Adidas released the Jabulani, just 8 bonded panels. Goalkeepers were furious. The ball moved in ways no one could predict. Aerodynamicists explained it. Fewer seams mean less aerodynamic stability. The Jabulani was too smooth. At certain speeds it knuckled and swerved unpredictably. Science had accidentally made the ball worse. Every change to a ball's panel count and seam pattern changes how it moves through air. The soccer ball is not just a shape. It is a fluid dynamics problem. For Qatar in 2022, Adidas introduced the Al Rihla, 20 connected panels with a textured surface, designed using computational fluid dynamics modeling. The algorithm had joined the team. And yet the ball is still between 27 and 28 inches around. The Football Association wrote that rule in 1872. 150 years of change, same size ball. The game played with this evolving object is now followed by more than 4 billion people, more than half the human beings alive today, by some estimates. Here is where the story takes a strange turn. The truncated icosahedron, the shape of the soccer ball, also appears in nature, at the molecular scale. In 1985, researchers discovered that 60 carbon atoms can bond in exactly the same hexagon and pentagon pattern as a soccer ball. They named the molecule Buckminster fullerene, after Buckminster Fuller. The geometry of a medieval pig bladder, refined over centuries into a sports object, turns out to be a shape that carbon spontaneously assembles at the molecular level. The universe has preferences. In a few thousand years, we went from inflating an animal's organ to discovering that its refined shape appears at the atomic scale of matter. That is the arc of the soccer ball. The sport has changed beyond recognition, the money, the cameras, the global scale. The ball endures, round, pressurized, descended from something that once squealed in a muddy English field. We did not invent the soccer ball's shape. We found it in ancient geometry, in carbon chemistry, in the roundness that nature returns to at every scale. We just learned to kick it. This is Origins. Subscribe and come back tomorrow. There's a new origin every single morning.